So, as with last time, definitely do not watch through the entire thing. Skip forward to the parts of the section B that you were stuck on and wanted me to review. Also, as with last time, I haven't gone through this paper before, so this isn't going to be slick or wonderful, but hopefully it'll give you an idea of my thought processes as I go. So, first question. Here we have a probability distribution given as a table. You might well remember these from about last Easter time. That's when we covered it. It was while we were doing distance learning. And the way this is set up is each of these is an event that might happen. So maybe you'd get 0, 1, 2, or 3. And down here is the probability of each of those happening. So the probability of getting 0 is A. The probability of getting 1 is 0.2. And so on and so forth. So when the first question asks you to find the value of A, you are going to be using a specific rule with probability, which is that one of the things in that table has to happen. So there isn't an alternative possibility. And what that means is these 4 probabilities must add up to equal 1, because it's certain that one of them happens. So in that case, we can use that to find A, because the other 3 sum to make 0.6. So you have A plus 0.6 equals 1. So A is equal to 0.4. The next question, I am not convinced that I have covered with you how to find the expected value from a probability distribution, but I'll go through it now because it's interesting for you to see. So to be able to find the expected value, what we do is we work out on average what will happen. And the way we do that is by multiplying each of these numerical possibilities by their probability. And so I'll multiply 1 by 0.2, 2 by 0.3, and 3 by 0.1. And then I add those probabilities together, and that gives me the expected value. So let's take a look at that. We'll have 0 times 0.4 plus 1 times. And if I take a look through that, it's going to give me 0 plus 0.2. And altogether that gives me 1.1. So my expected value is 1.1. For B, we've got a probability distribution, but this time we're missing 2 pieces of information. And you'll notice it's a 7-mark question, which is quite big, and it's asking you to find the values of B and C. So let's take a look through and see what information we can take out of this. It says Toby takes part in a sports match. A random variable y represents Toby's winnings in euros. And you'll notice one of these is negative. That's, I'm assuming, if he loses the sports match, then he will lose 2 euros. And then there's also the probability that he'll win 1, 2, or 3 euros. It gives us the probability distribution, and then it tells us it is known that the game is a fair game. That is the essential bit for us, and it asks us to find the values of B and C. So, whenever you see that a game is a fair game, that is telling you that the expected value is equal to 0. Because if it's a fair game, then you're equally likely to sort of win money as lose money. And so on average, you should win no money at all. And that is, in IB exam question terms, what makes it a fair game. So we have that the expected value should equal 0, but we have 2 missing pieces of information. We're missing B and we're missing C. So we can't find 2 unknowns with only 1 equation. So we need to use something else. And actually, we can use what I've highlighted in green on the previous question, which is that all of these should also add to equal 1. So let's write down both of those equations. So we know B plus C plus 0.3 equals 1. And if the expected value equals 0, I know minus 2b plus c plus 0.2 plus 0.6 equals 0. So I've got a problem involving simultaneous equations here. The first thing I'm going to do is tidy this up so I have all my letters on one side and my numbers on the other. So b plus c equals 0.7 and minus 2b plus c equals minus 0.8. We've got a couple of different options for this. I think what I am going to do is subtract this equation from this equation, because that way I'll be able to cancel out my c's nicely. So b plus c equals 0.7 minus, and I'm going to put it in brackets first so I can't accidentally lose a negative. So minus 2b plus c, and that equals minus 0.8. The first thing I'm going to do is take my time and multiply through by that negative. So b plus c equals 0.7. And now I've got a positive 2b minus c. And then that's now a positive 0.8. And now I can just add those together and it will cancel out my c's. So those will add together to equal 0. I have 3b here plus 0 equals 1.5. So if 3b equals 1.5, b equals 0.5, and then I can use one of my other equations to work out what c is. So b plus c equals 0.7. If my b is 0.5, then c is equal to 0.2. So there we go. Those are my two final answers for question 8. Right, next question. So this question is a quadratics question, so it takes us right back to one of the first topics that we covered together. I think this is a nice one because it tells you, it wants you to use the discriminant. We know there's lots of kind of harsh questions out there which don't tell you that you're going to need to use the discriminant. So the first thing it says is find the discriminant of this quadratic in terms of k. So let's write out the formula for the discriminant first. B squared minus 4ac, that's in the formula booklet. And also let's write out what our a, b and c equals. So my a, there's nothing in front of my x squared. So my a is 1. There's a 6 in front of my x. So my b is 6. And then finally my c is this entire thing in brackets here, 8 plus k, because k is an unknown, it's not the variable. Now I can substitute those into the discriminant. So I have 6 squared minus 4 times 1 times 8 plus k. And I'm going to be really careful multiplying this out now. So 36 minus 4 times 8 plus k. And I need to multiply that 4 into both parts of that bracket. So 4 times 8 is 32 plus 4k. And now I'm going to deal with that negative so that I don't accidentally lose it. So I've got 36 minus 32 minus 4k. And when I do my final step of simplification, that gives me 4 minus 4k. The next thing it tells us is that our function is always greater than 0 for all values of x. State with reasons the set of values that can be taken by the discriminant and by k. Now let's just sketch that so we can see what it looks like. My function is a quadratic where the coefficient on x squared is positive. So that means it's making a smiley face, it's a U-shaped quadratic, and it's a U-shaped quadratic that is always greater than 0. So our function is going to look something like that. And what that means is if it's always greater than 0, then our discriminant is going to be negative because there are no x-intercepts along here. So my first thing is I know my discriminant is going to be less than 0. It asks you to give a reason as well. So my reason is because there are no x-intercepts. So that's part I. And then for the second part, it asks us to give the values of k. So now, instead of writing d is less than 0, I'll write our expression for d, which was 4 minus 4k is less than 0. So 4 is less than 4k. And we can divide through by 4. That won't swap our inequality because it's positive. So I have k is strictly greater than 1. And in terms of justifying that with a reason, well, it's okay. This is our reason. So as long as you've worked it through step by step, that counts as a reason. So C, it says write f of x in the form f of x equals x plus p squared plus q. That is like a completed squared form. And q needs to be an expression involving k. That's okay. Let's first just rewrite out our quadratic. So it's x squared plus 6x plus, what was that, 8 plus k. So remember, when we're putting a quadratic into completed squared form, the first thing we do is we halve the coefficient on x. So we halve this number here and we put it with the x in a bracket. So we'll have x plus 3 squared. Then we subtract this number squared and we keep this number on the end here. So plus 8 plus k. I can tidy that up a little bit. So I'll have x plus 3 squared minus 9 plus 8 is like minus 1 plus k. It's asking for q as one single thing though, so we could just say q is equal to minus 1 plus k, and our p is equal to 3. The next question says, explain how the form obtained in C confirms the answer to B part 2. So we know, that's a really interesting question. I probably should have read this before. Right, so let's get this right. This is our completed squared form. It's also called the vertex form. And the vertex on any quadratic is its maximum or minimum point. And what we know is with the vertex form, this value here, if we take the opposite of it, so minus p will give us where the sort of x value of that vertex is, x coordinate of vertex. And q, we don't need to swap the sign on that one. Q is our y coordinate of the vertex. And so if we know that this vertex has to be above the x-axis, we know that the y coordinate of that vertex must be greater than 0. So we know that q must be greater than 0. So if we substitute in our expression for q into there, we've got minus 1 plus k is greater than 0. If I sort of take that one to the other side, then I have k is greater than 1. And that is exactly the same as what I said up here. So that is why our answer to part C can confirm our answer to part 2B part 2. Oh, I really like that question. Right, final question. It says, if k equals 4, write down the minimum point of the quadratic. Oh, that's nice. So now we're just going to take k is equal to 4. We know that our minimum point has an x-coordinate of -3. We always swap the sign on whatever's in the bracket for the x-coordinate. And then for the y-coordinate, I'm going to substitute 4 into q. So -1 plus 4 is equal to 3. I don't need to swap the sign on my y-coordinate. So my coordinate of my vertex is -3. 3. Right. So my final question, question number 10. This is always where it gets difficult, but that's okay. That's a lot of writing. Okay, what does it say? So, a farmer has a tractor in a field at point A. Let me start drawing this out. So here's point A, and it is 2 kilometers due south of point B. So B is 2 kilometers north of A, and that distance there, right? So a farmer has a tractor in a field at point A, 2 kilometers south of point B, on a road which runs from west to east. I'm going to change colour for my road. So there's a road going through A, running from west to east. Road. There we go. The farmer wishes to get to point C, which is 2 kilometers east of B. Just in case you have forgotten, never eat shredded wheat. There we go. So 2 kilometers east of B is C. That's also 2 kilometers. East of B. Oh wait, hang on a second. Which is 2 kilometers east of B on the road. I thought the road was going through point A. Let me reread this. A farmer has a tractor in a field at point A. Oh, okay, I get it. Point A is in a field. 2 kilometers south of point B on a road. I'm going to be honest, there are a lot of commas there, and that is not very clear. But later on, I get it. The road is going through point B instead. Let me erase that. Thank God for iPads. Sorry, guys. I told you I hadn't looked at the questions before. Right, here's my road. The road's going there as well. Right, try again. The farmer wishes to get to the point C, which is 2 kilometers east of B on the road. The tractor travels at 20 kilometers an hour on the road and 12 kilometers an hour in the field. So how can I write that down? So 20 kilometers per hour on the road and 12 kilometers per hour in the field. The tractor will travel in a straight line across the field to join at the point P, X kilometers east of B. Right, so there's an extra point P. I'm going to put it there. This distance here is X. And, oh, the first question asks you to sketch a diagram of this information. Voila, I've already done it. You probably don't need those speeds here really in it, but everything else, something looking like this would be appropriate. You also don't need your compass on here unless you want it. Right, then it says, show that the total time t for the tractor to travel from A to C is given by that rather complicated looking function there. So if I ever think about this, there's two different things going on. There's the time the tractor takes to travel from A to P across the field, and I know that's going to take 12 kilometers per hour. And then there's the time it takes to travel from P to C, which will take 20 kilometers an hour. So I can already, if I'm looking up here and trying to piece this together, that 12 looks like, that 12 looks like this whole expression is about this part of the journey here. And then this 20 is making me think that that part of the expression is about traveling this distance here. So if I want to work out how long it's going to take me to travel from A to P, I need to know how far it is from A to P. This here will form, let me draw it in, a nice little right angled triangle. There we go. So my distance from A to P is going to be 2 squared plus x squared square rooted. I'll just expand that 2 squared, so we've got the square root of 4 plus x squared. Now please, please, nobody actually square root 4 and then square root x squared. It doesn't work out. Try it with a few numbers and you'll see. So our distance from A to P is given by the square root of 4 plus x squared. So then we know we've got speed equals distance divided by time, but I'm looking for time, so I can rearrange that and say time is equal to distance divided by speed. Some of you will use one of those triangle things to rewrite that. But if we want the time it takes us to travel from A to P, so time from A to P, then it's going to be the distance, which is the square root of 4 plus x squared, divided by the speed, which is 12 kilometers per hour. It doesn't need the kilometers per hour. There we go. And then the second part is looking at how long it takes to travel along this part here. So we need the distance again from P to C, and that is going to be whatever is left over after the x. So 2 minus x makes a lot of sense. Distance from P to C is 2 minus x. And my time from P to C then is going to be 2 minus x divided by my speed, which was 20. So then this formula here makes a lot of sense. It's going to be this plus this for my total time. Please note though that this is a show that question. So even if you look at that formula and you're like, yeah, okay, cool, it all makes sense. You know, the answer's already given. So what that means is you have to show how you've got to that answer really clearly. So things like me writing down, okay, here's how I got the distance from A to P. Here's me writing out my formula to find the time. Here's me sort of piecing it all together. All of that is important. That's how you pick up the marks in a show that question. Right, the final question says, use calculus to find the value of x that minimises the journey time t. An 11-mark question. That is just crazy, but I love it. So, if we're looking at minimising something, we are looking for a minimum point. And one of the things we know about minimum points is that their tangents are horizontal. So the gradient at a minimum point will equal 0. And that's what it means when it says use calculus to find the value of x that minimises the journey time t. So the first thing I'm going to do now is differentiate my function for t to find the gradient function, and then I'm going to set it equal to 0. So let me find a bit of space down here. So t of x is equal to the square root of 4 plus x squared over 12, not 20, plus 2 minus x over 20. Step 1, differentiate it. This isn't going to be ridiculously simple to differentiate. I mean, it is the final question on an IB paper, so it shouldn't be that simple to differentiate. But the things I'm going to pick out here to watch out for as I differentiate are these sort of divisions here. They're only divided by a constant. So my plan is to, I don't want to say ignore them, but I'm going to differentiate the bit with the x. And then that's just like it being multiplied or divided by a constant. So I can just bring that back in again at the end. So I don't need to worry about the divided by 12 or the divided by 20. And I'm not going to let it impact the rest of my process. The other thing to note is here I have a function inside a function. So I'm definitely going to need to use the chain rule to differentiate that. So if I take a look, here inside 4 plus x squared is my blah. Let me highlight it. So 4 plus x squared is my blah. So I've got the square root of blah as what I want to differentiate. There we go. And if I differentiate the square root of something, the square root of something is like that something to the power of a half. And now I'm going to use my just my normal polynomial differentiation rule. So I multiply by my power. So I'm now going to have a half times blah. And I reduce my power by 1. And a half reduced by 1 is minus a half. I put back in my blah, so 4 plus x squared. And I multiply by blah differentiated. 4 differentiated is 0, x squared differentiated is 2x. And let's not forget that divided by 12. I'm just going to bring that in there at the end. The next part doesn't need the chain rule because there's not a function within a function. So I'll keep my divided by 20 down there. I differentiate 2, I get nothing. I differentiate x, I get minus 1. Right. That's all fine, we've differentiated it, but now we need to solve it equal to 0. And at the moment, the bits that are troubling me about solving this equal to 0 are definitely this negative a half power up here, because I know that, what am I trying to say? I'm always about, like, when we want to differentiate or integrate, swapping the square root for a numerical power, because for differentiating and integrating, that numerical power is easier to deal with. But now I'm trying to solve this, looking at the power and negative a half isn't going to help me solve this. So I'm going to be better off now swapping that back to the square root, and the negative is going to make it a reciprocal, because that's going to make the rest of it easier to solve. So, there we go. The first thing I'm going to do is I'm going to definitely write a square root over this for that half. And the negative means I'm going to bring it down to the bottom of the fraction. So I've now got a half. I've still got that 2x up there, so let's not lose it. Over the square root of 4 plus x squared. And I'm going to just bring that 12 to the beginning now instead. And I'll keep that plus minus 1 over 20 over there so I don't lose it. And it's still equal to 0. I can carry on simplifying this now. So one of the things I can do is I can see that I've got a half times 2x. So that is just going to become 1x. And the other thing I'm going to do is I'm now going to just sort of bring that minus out to being in front. So I've got minus 1 over 20. So now I have x over 12 square root of 4 plus x squared minus 1 over 20 equals 0. So I am trying to solve this so that it equals 0. I think the first thing I'm going to do is bring that 1 over 20 to the other side. of my equation. And then I think I'm going to end up sort of multiplying up by this, but we'll see how it goes. So x over 12 root 4 plus x squared equals 1 over 20. And then, yeah, I'm going to multiply this 20 up to the top here, kind of like cross multiplying, and I'm going to bring this up over here. So if I rewrite that out, I have 20x equals 12 square root of 4 plus x squared. My feeling is to be able to solve this, I want to remove that square root. But the only way I can remove that square root is by squaring everything else. So I'm actually going to bring that 12 over and sort of divide it on this side before I do my squaring, because I think it's going to make it a little bit neater. So, I'm running out of room. Let's hope we resolve this quickly. I'm going to have 20x over 12 equals the square root of 4 plus x squared. And now I'm going to square both sides. I'm going to bring my working over here though. So if I square the left-hand side, I will have 400x squared over 144. And if I square the right side, I'm just removing that square root. So I've got 4 plus x squared. It's looking better. It's definitely looking better. Ironically, now I'm going to bring that over 144 back on the other side. I just like to take it out of the way so that it wasn't messy. I wasn't going to sort of mess up that squaring process. So I now have 400x squared equals 4 times 144. 144 times 4, so we've got 16, another 16 and 4, there we go. So 576 plus 144x squared. I'll now minus the x squared across to the other side. So we've got 400 minus 144 is 256. X squared equals 576. I feel like I've gone wrong somewhere. 4 times 4 is 16. What I really wanted to happen, if I'm honest, is that I could divide. Maybe it's going to work out. I'm just going to check the answers to be sure. There was definitely an easier way to do this. There was a division by 4 earlier on that would have saved me a whole load of hassle. Okay, I'm going to carry on like this, but let me just point out to you where I could have saved myself a whole load of hassle. All the way back here, I had 20x equals 12 times something, and so I could have divided both sides by 4, and I would not have this division to do here now. So what I'm about to have to do is x squared equals 576 divided by 256. If you get stuck in a situation like this, here is one option. You could not simplify your fraction and just say, okay, I know x is going to be plus minus the square root of 576 over 256. That's not perfect because that's definitely not a simplified fraction because they're both even, but it's an answer. You'd probably lose 1 mark for having it not fully simplified. The other option is to try and simplify. I'm going to bring my process up here. We're going to have to try and simplify 576 over 256, which is something I've been doing recently with my grade 6s, ironically. So first thing I notice is it's even, so I'm going to divide top and bottom by 2. So 576 divided by 2 is 288. Is that right? Hang on a sec. 576 divided by 2, so 2 remainder 1. 89. Remainder 1, 4. That was not right. Right, so 294 over 256 divided by 2. So 1, 2, 8. 128, nice. And then I can divide both of those by 2 again. So 294 will be 147. Hang on a sec, I really feel like I've gone wrong. I'm not quite sure where I've gone wrong. I'm going to do it on my calculator. That is such cheating, but there we go. Otherwise this video will be really, really long. How did I do a division that badly? 576 divided by 2 is 288. What was I playing around with? Okay, let's not talk about it, guys. It's okay. Yeah, I did that division really badly. Please don't tell my grade 6s, guys. They would rip me apart. Okay, 288 over 128. That is looking a lot more promising, I have to tell you, because then when I divide it by 2 again, I get 144 over 64. Yes. Which is a square number. Woo! Should we keep dividing it or should we square root it there? I feel like, what do I want to do? That's 12 squared over 8 squared. Let's square root it now. I'm being chickeny. I don't want to keep dividing and then make it something hard to square root. So now I've got x squared is 144 over 64. So my x is equal to positive or negative square root 12 over 8. Sorry, without the square root. Where's my... There we go. Positive or negative 12 over 8. And then that's going to be really easy to simplify because 12 and 8 both divide by 4. So it's positive or negative 3 over 2, which is good. The only final thing to note is our x was a distance. If we come all the way back up here, there was our x. It's a distance, so it's got to be a positive value of x. So my very final answer, guys, after all of that, was x equals 3 over 2. I'm so glad I'm done with that. Right, well, that's what an 11-mark question will do to you, but we've managed to find it in the end. Let me know if you have any questions about that, and maybe it will be nice for you to see me struggling with doing basic division. My excuse is I brought a coffee with me to start this and I never got around to drinking it, so I was minus a coffee while I was doing that working. Right, see you guys later, bye.